Hello everyone. Today we are going to solve an elliptic Diophantine equation. So we are going to find all integer solutions x and y for this quadratic equation. First of all, why this equation is called an elliptic equation? Of course, the reason is that the graph of the equation is an ellipse. Let's take a look of the graph. The equation x squared plus 2xy plus 3y squared plus 4x plus 4y equals 2. And the graph is like this. We can take a look. This equation, the graph is bounded. You see, the x value is between -5 and 1. The y value is between -2 and +2. So within this range, there's only finitely many integer points to consider. In general, a quadratic equation ax squared plus bxy plus cy squared plus linear terms equals 0 is elliptic if and only if b squared minus 4ac is negative. As I just mentioned, the variable of such equations are bounded and there are only finitely many lattice points within the bound. To solve the equation, we first rearrange in terms of x. So we got x squared plus 2y plus 4 times x plus the rest terms equals 0, which is a quadratic equation in x. We are looking for integer solutions for x and y. That means the equation must have real solutions. So for quadratic equations, its determinant must be non-negative. So we establish an inequality in terms of y. We simplify it, we got y squared less than or equal to 3. For real values of y, so y can be between negative square root of 3 and the positive square root of 3. If we only look for integer solutions, there's only 3 possibilities. Y equals -1, 0, and 1. Now we are ready to find all the integer solutions for the quadratic equation. 3 cases, when y equals 1, we plug in. We got a quadratic equation for x. Solve that, we got x equals -3 and 1. So we have 2 pairs of solutions for x and y. Then we plug in y equals 0. We got another quadratic equation for x. This time, we don't have any integer solutions. Finally, we plug in y equals 1. We got another quadratic equation for x. We have another 2 solutions for x. So finally, we have 4 pairs of solutions for x and y. Exercise: find all integers x and y such that x squared plus 2xy minus 3y. I switch the sign of the y squared term, and plus 4x plus 4y equals 1. This time, the equation is no longer elliptic. We can check. We have negative 3 here, and this is 1. It's a hyperbolic equation. So this equation is no longer bounded. That means we have to solve this equation for integer solutions in a different way. In general, solve this type of equation is much more difficult than the elliptic equations. Fortunately for this one, we have some special technique to solve this equation easily. I leave the fun for you, and this might be a future video. Thank you for your attention.